Good afternoon and welcome to this lecture. This is lecture number 9 and we are dealing with constraint motion. In the last class, we had seen some example of constraint motion, and I think we were dealing with this question where, if you just go back a bit, we had seen how do we find out this string constraint. To find out this string constraint, it is very simple. You just have to find out the work done by tension, and you just use that work done, tension multiplied by the displacement multiplied by cos of the angle, and you end up with the string constraint, the relation between the various masses. Do we remember this, yes or no? We had solved a couple of problems on that as well, and I think we were dealing with this problem. Someone gave me the answer as well. Let us quickly go through and see how are we supposed to find out the string constraint. Remember, I told you that whenever we are talking about the string constraint, we'll assume one direction of motion, and our string constraint would be according to what we have assumed. What we have assumed here is this M2 block goes down with X2, and this M1 block comes up with X1. We have to find out the relation between X1 and X2, V1 and V2, A1 and A2. And how are we going to do this? We will just draw tension T, 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 and T. Now, once you have drawn the tension in the first string, I can draw the tension here, 2T, 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 and 2T. Now, to find out the string constraint, you must understand that this pulley does not move. This pulley does not move. This pulley moves, but tension upwards and tension downwards are same. Mass, pulley is massless. Don't have to think about the constraint of this. We just have to find out the relation between x1 and x2. So how do we find the relation between x1 and x2? If I call x1 as the blue mass, t is upwards and x1 is upwards. So what is the pink mass? What is the work done by tension on this string, the pink one? It will be t into x1. We understand this? Now, if I think about this green mass, this bigger mass, this green mass, it is moving down, x2, 2t is upwards, 2t is upwards. So if I talk about the total tension becomes 2 plus 2, 4, 4t, and it is moving downwards. So angle becomes 180. So the answer for this one, the work done by tension here becomes minus 4t into x2. That must be equal to 0. Work done by tension should be equal to 0. Tension cannot become 0, because if tension becomes 0, they are not related to each other. So I get x1 as 4 times of x2. V1 becomes 4 times of V2, and A1 becomes 4 times of A2. Do we understand this? Yes or no? But remember, the problem is still not over. We just have not solved the problem. So once you find out the string constraint, you'll have to solve the problem also. You'll have to solve the problem also. How many of you got this constraint correct? First tell me that. Girls got it, boys? No one got this? Okay. So now remember, getting the constraint is just the first part of the solution of the problem. The problem is still not solved, because the problem may not be simply just to find out the relation. It may be something else. You might have to find out the actual values of acceleration of these two blocks. How would you proceed then? So the first step is already, we have to find out the constraint relation. We have found out. What would be the next step? The next step is we complete the free body diagram of these two bodies. This body has a weight M2G. This body has a weight M1G, both going downwards. Weight is always downwards. Now, we have assumed that the Body of mass m2 is going downwards. That is how I got the constraint. So I will have to assume that it is moving downwards. Let me say that this moves downward with an acceleration. Instead of calling it as a2, let me call this acceleration as a. Body m2 moves down with an acceleration of a. Then we know the constraint relation, that the acceleration of body 1 will be 4 times of body 2. So if the acceleration of body number 2 is a, what will be the acceleration of body number 1? Again, it has to move upwards. It will be 4 times a. Yes or no? Now we have to move ahead and solve the equation and get the value of t and a. How are we going to do this? We look at this green block, and now we can write the green equation of this block. What will be the green equation of this block? Remember, this block is moving down. Can anyone tell me what is the equation of motion of this block? We have done it 1500 times now. What is the motion of this block? What is the equation of motion of this block?
M2G plus M2G minus M1G by M1 plus M2.
I asked you the equation of motion of this block. I don't know what you are telling me. I absolutely have no idea what you told me. Absolutely zero idea. Try again.
M2G minus 40.
M2G
That's 40.
minus 40. That's it. Nothing else. We have done it so many times. Even though I have told you shortcuts of everything, I have always made the equation. Yes. What is the equation of the block M2?
M2G minus 40 equals to M2A.
Yes, that is what it is. The downward force is M2G. The upward force is 4T. And this block is moving downwards. So M2G minus 4T is equal to M2A. That is the equation of motion of this block. Very correct. Let us now move on to the equation of this block. This is moving upward, the pink block moving upwards with 4A. Tension is T. Weight is mg. What is the pink equation of this block?
M1G minus T is equals to M1A.
Think again.
M1G minus T is equals to M1A.
Think again.
T minus M1G is equal to M1S.
Open your eyes. The universe, the 4% of which we see, is beautiful. Open your eyes. Look at the diagram. Look at what I've highlighted. Try again.
For T minus M1G equals to 4MA.
Ah, that is correct. It is moving upwards. So T minus the downward force is M1J is equal to the mass m1. Its acceleration is not a, my dear friends. That is what we have been doing for the past class. We have been finding the relation between m2 ka acceleration and m1 ka acceleration. It is not a, it is 4a. So it has to be multiplied by 4a. Now we have two equations. Now we can solve these two equations. I cannot make a shortcut out of here because now it is the accelerations are not same. So you will have to do it by the original method. Now you have to eliminate either t or a. You can eliminate t also, you can eliminate a also. This is simple equation in two variables, a very simple equation in two variables. You should be able to calculate this and tell me the value of acceleration. I'll give you 1 minute to do it. Tell me what is the acceleration coming. Tell me how much is the acceleration coming. Remember, after this point, physics cannot help you. It's all about your, I will not even call it math. It's all about your calculations. Calculations are not maths. What is the value of A coming? Yes. Now that is what you need to practice. When you get these equations, it should not take more than 5 seconds for you to solve it. If it's taking more than 5 seconds, that means you are not doing good enough. I can solve it in 5 seconds. And I am a 42-year-old fellow whose brain has stopped working. I can solve it in 5 seconds. Anyone? You should be at least 5 times more faster than me. So if I can solve this it in 5 seconds, you should be able to solve it in 1 second. Look at the equation, you tell me the answer. And you have taken around 1 minute.
Minus 4 m1 into g by m2 plus 16 m1.
Yes, you should have given the answer in a flash. M2 minus 4 times M1 multiplied by G upon M2 plus 16 times of M1. You should have given the answer quicker. What is my way of solving it? My way of solving it is not very fantastic. I just multiplied this by 4 and then add both the equations. So I multiply it by 4 in my head and I eliminate t and then I write the answer. I could do it in 5 seconds. You could do it better. Do you understand this? Yes or no? So that is the final answer that you get. Getting the constraint is just one part of the problem. It is not the entire problem. Just one part of it. Do you understand this? Huh? Now, can I give you a problem and expect that you can get it done? Or not? Chalo?
Then, sir.
Then the problem comes. And remember, you have to tell me the acceleration. First of all, you have to tell me the constraint relation, and then you need to tell me the acceleration. So here comes the first problem. So I've got this arrangement of two masses m1 and m2 and a force F is applied here. There's only one way in which this system can move. Where can this system move? There is no friction, so don't worry about the friction part. Where can this system move? Yes, my dear friends.
Right side.
Yes, it can only move right side. So if I say that this gentleman moves x1, or the velocity is v1, or the acceleration is a1, where will m2 move? This is no physics. This is common sense. There is no physics involved here.
Right side.
Okay, it also has to move right side. So your first task will be to find out the relation between x1 and x2, v1 and v2, a1 and a2. That would be the first task. The second would be to find out the acceleration of this system. What is given to you is the force F. What is given to you is the mass m1. What is given to you is the mass m2. So F, m1 and m2 are known to you. G is always known to you. Two parts of this question. First, you have to find out the constraint relation, and then you have to solve this. You will have 2 minutes to do this. Your time begins now.
So 2x1 is equals to x2.
2 times x1 is equal to x2. That is correct. But again, you have to tell me the acceleration of block m1 and acceleration of block m2. The first round is passed. Let us see if you can pass the second round. Well done. Everyone got this relation? X1 is 2 times. So x2 is 2 times x1. Yes or no? Well done. How are you supposed to get this? So let me just draw the tension T, 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 T. This would be 2T and this would be 2T. I look at this pink block. I'm just finding the constant relation. I see here 2T and I see here x1. So I can write. I hope you can see it now. So I can write 2T into x1. 2T is in this direction. X1 is in this direction. So the work done by tension for this block, would be minus 2T into x1. Then I move on to my favorite green block. Green block tension is forward. This block is also moving forward. So what is the work done by tension here? Plus T into x2. That must be equal to 0. T is definitely not 0. So I get the relation 2 times x1 is equal to x2. That is the constraint relation. So basically it means that if this block is moving here with an acceleration a, and remember, don't make a mistake here. If this block is moving here with an acceleration a, This block, the oops, wrong color. This block, the green block, will also move here, but not with the acceleration a, but with an acceleration 2a. Do we understand this? Yes or no? Just gone above it saying bye bye, bye bye, sir. Ho gaya. Bye bye. Okay, now do we have the value of a? Anyone? Shall I do it for you? You shall have 2 minutes to do this. Get the answer and stay happy. No one there with an answer? Shall I do it? Huh? Chalo then. Comes my turn to do this.
4m2 plus m1.
What is in the numerator?
4m2 plus m1.
Okay, let me do it. This is M1G and this is N1. Yes, someone was saying anything? Yes, beta?
If by M1 plus M2.
No, that is not correct. It's not F by M1 plus N2. Okay, so first I draw this. It is not moving in this direction, so I can write the blue equation, which may not be of much use, but sometimes it will be of use. N1 is equal to M1G. We are not going to use it here, but yeah, sometimes we might use it. Let us look at the pink equation, which is of our prime importance. F1 is forward, 2t is backwards, and acceleration is forward. F is forward, 2t is backwards, and acceleration a is forward. What is the pink equation of this block?
F minus 2t is equals to m1a.
Yes. F minus 2t is equal to m1a. That is absolutely correct. This is the pink equation of this block. Let us now move on to the next block. Oops, wrong color. I hate wrong colors. The weight of this block is M2G. The normal reaction is N2. I can write the yellow equation, N2 here, M2G here. I can write the yellow equation, which is of no use right now, but it will be of use somewhere sometimes afterwards. So N2 will be equal to M2G. We understand this? It is not going to move duck, 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 duck like this. Let us come to the equation which matters most. The equation which matters most is the green equation. T1 is forward. There is nothing on the back side, and the acceleration is forward. What is the green equation of this block?
T is equals to 2m2a.
The green equation is T is equal to M2 multiplied by 2a, because the acceleration is 2 times of a. That's it. It's a very simple manipulation. You just multiply equation number 2 by 2 and then add it, and you will end up with the answer, and the answer is acceleration would be equal to F divided by what? M1 plus 4M2. That is the answer, my dear friends. Anyone got this answer? That's it. Now, have a look at this. If you have any problems, please ask me. Wherever you have problems, please ask me. Once you are done, let me know, then only I'll move forward. Once everyone has understood this. If you have not understood this, bacha, please ask me. Please.
Completed, sir.
Completed, everyone? Shall we move on to the next question?
Sir.
Here comes the next question. Question number 3, let us call it. In the system shown in the figure, and I hope you can see the figure. In the system shown in the figure, block M1 is given, slides down a frictionless inclined plane. So it is given that M1 is going down. No questions asked, no answers given. The pulleys and the strings are ideal. We are supposed to find the acceleration of both the blocks. As you can see, my dear friends, both the blocks are not connected by one string. They are connected by two strings. So you know the process. You know how to do it. Best of luck. You have 2 minutes to give me the answer. And you already know that M1 is going down. So the first thing would be to get the constraint, bacha. If M1 goes down by X1, and it does not require rocket science to understand this, if M1 goes down by X1, where will M2 go? Huh?
Upwards.
Upwards. So first of all, you will have to find out the constraint relation between X1 and X2. And then you will have to solve the equations, get the answer, and stay happy. Your time starts now. Anyone got the constraint relation? No one got any answers? Huh?
2x2 is equal to x1, sir.
2x2 is equal to x1, sir? What, sir?
2x1 is equals to x2.
Yes, 2x1 is equal to x2. You got the wrong constraint, beta. You got the wrong constraint. The first thing is to get the constraint relation. Let me go about it. Let me call this as T. So this is T, this is T, and this is T. T plus T, this becomes 2T. This becomes 2T. This becomes 2T. And this becomes 2T. The pink block and the green block come into the picture. This is the pink block. 2T upwards, x2 upwards. What is the constraint relation of this block? What is the work done by tension on this block? 2T and x2 in the same direction. 2T, x2. Let me now come on to my friend blue block. The blue block, x1 is down and t1 is up. What is the constraint relation? Minus t into x1 is equal to 0. So the constraint relation was correct, given by the girl. The other one was wrong. Remember, there is a high probability that you can just say the opposite one, and that is why I write it very carefully. So the constraint relation is 2 times x2 is equal to x1. 2 times x2 is equal to x1. That means if this block moves up with an acceleration a, m2 moves up with an acceleration a, m1 will move down with an acceleration 2a. Do we understand this? Yes or no? Now we have the simple problem of solving this, getting the answer and staying happy. Anyone got the answer? So I will continue with this. The weight of this block is m2g downwards. Now I can write the pink equation of this block. Everything ping, 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 ping. Tension is 2T upwards. Weight is m2g downwards. And acceleration is t upwards. What is the pink equation?
2t minus m2g is equals to m2a.
2t minus m2g is equal to m2 into a. That is correct. Now let us move on to the blue block. For the blue block, remember the weight is m1g downwards like this, but I will have to resolve it because this block is going to move like this. So this component will be m1g sine theta. Do we remember this? Yes or no? No or yes? And this component will be m1g cos theta, my dear friends. But wait. There is one normal reaction also going upwards, normal reaction upwards. Let me call this N1. Let us first discuss the yellow equation. N1 is upwards and M1G cos theta is downwards. So what is the yellow equation? We don't need it now, but we'll need it sometimes. The yellow equation is very simply which one? N1 is equal to M1G cos theta. We don't need it right now, but there would be a time when we'd be needing the value of this normal reaction. Anyways, let us concentrate on the equation which is of importance. The blue equation. The blue equation, T is upwards. M1G sine theta is downwards. And the acceleration is downwards. Downward. Can I have the blue equation, please? Huh? No one knows W equation. Simple.
E minus m1g sin theta is equal to m1 2s.
Open your eyes. 4% of the universe is that we see. It is beautiful. Open your eyes.
2m1g sin theta minus t is equals to 2m1a.
Open your eyes. Take a deep breath. Open your eyes and see this beautiful world. Only see what you see. Don't see what you don't see. Try again. Look at the blue things. And that is why I draw all these graphs and arrows. Yes. Yes.
Sorry, 1g sin theta equals to 1g.
Not able to understand everything, but if you have opened your eyes,
m1g sin theta minus t is equals to 2m1a.
yeah, see, this is how you get the answer when you open your eyes and do it patiently. The downward force is m1g sine theta, not 2m1g sine theta. Mass is m1. Downward force is m1g sine theta. Upward force is t. It is going down, my dear friends. So m1 multiplied by 2a. Only with acceleration it is 2. Now it is the simplest problem in the entire universe. Anyone can do this. Add the two equations. Dung dung dung. Tell me the value of a. What is the value of a that we are getting?
Is equals to 2m1 sin theta minus m2 into g by m1 m2 plus 4m1.
Yeah, well done. I hope that you are giving the answer so confidently. So it must be correct. So it will be 2 times m1g sine theta minus m2g. I can take g common, divided by 4. 4 times m1 plus m2. That is the answer. Do we get this? Yes or no? Huh? So it all depends on how these blocks are connected. Therefore, I cannot give you a general formula for this because the accelerations are different. The general formula can be made when accelerations are same because you can treat them as one body. Here we cannot treat them as one body because they are moving with different magnitude of acceleration as well. Do we understand this? Is going about saying bye bye? Yes, sir. Okay. Done. We're done. Everyone has noted this down? Huh? Comes the next one. And remember, you don't have to do anything extravagant. We are simple people and we do simple things. Have we done this problem before? Have we done this problem before?
Yes, sir.
Yes, sir. Pakka, sir.
Sir.
You've given your answers too quickly, my dear friends, because now I have a third gentleman coming here, M3. Now we have 3 blocks. Now there's only one way the system can move. There is no other way with which the system can move. Where this system will move? Huh?
Downwards.
Downwards. So first thing would be to find out the constraint, my dear friend. Let's see who can do this. This moves downwards with x2. Then what about this block, M1? Where will it move? Huh?
Right side.
It will move here, x1. What about M3?
Side.
So the first thing would be to get the relation between x1, x2, and x3. And again, you don't have to do anything extravagant. Simple things. Put together, and we are done. You have 2 minutes to solve this. First of all, tell me the constraint relation.
Sir, x1 plus x3 is equals to 2x2.
Well done. So now you understood that even just by looking at the diagram, you should be able to tell me the constraint relation. That is correct. X1 plus x3 is 2 times x2. Just looking at the diagram, you can give the answer. Good. See, don't have to do anything extravagant. T, 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 and T. This gentleman is 2T. This gentleman is 2T. You can look at the pink block. 2T, x2 in the opposite direction. So the constraint relation for this is, the work done for this is minus 2T x2. Look at our green block. X1 is forward, T1 is forward. You can put it here. T x1. Look at our blue block. X3 is forward, T is forward. You can put it here. T into x3 plus T into x1 minus 2T into x2 must be equal to 0. From here, you get this revolutionary constraint. X3 plus x1 is 2 times of x2. Do you understand this? Or this is going to say, sir, ho gaya, done. Now, you just have to do simple things. We have 2 minutes to do those simple things. Do those simple things, get your answer, stay happy.
Sir, acceleration is equals to 2g by 3m2 plus m1.
Whose acceleration? M3 did not come. Is it possible? Not possible. Not possible. Now the problem is, I cannot call one as A and the other one as 2A and the other one as 3A. I just can't call this because there are no relation. Relation is between x3, x1 and x2. There are 3. So what do? Nothing. Let me call this acceleration as A2. Let me call this acceleration as A1. And let me call this acceleration as A3. Now I make the pink equation. Before making the pink equation, I have to draw the free body diagram. This is M2G. Look at the pink stuff and tell me what is the equation of the pink block. Everything is in pink. Yes. Huh?
M2G minus 2T is equals to M2 2A.
2A? How did you get 2A? Universe is beautiful. Only see what you can see. Don't see what you don't see. Try again.
Equals to
M2G minus 2T
equals to m2a2.
M2A2. There is not 2A, 3A, 4A. Okay. This is the pink equation. Well done. Let us now move on to this blue gentleman. And when we move on to this blue gentleman, This is M3G and this is N1. We mark them yellow. I am not concerned with this yellow equation right now. This yellow equation is going to give me N, oh sorry, let me call this N3. N3 is equal to M3G. I do not need it right now. Sometimes I will need it. I am more concerned about the blue equation. What is the blue equation? A3 is aage, T is aage, M3 is aage. What is the blue equation? Yes. Huh? What is the blue equation? Sir, we don't know, sir. What is the blue equation? Universe is beautiful. Just look. Draw it correctly. What is the blue equation?
T is equals to M3 A3.
That is the blue equation. As simple as it gets. T is equal to M3 A3. Let us move on to the green block. Again, I have this M1G gentleman. He does not go anywhere. This is N1G. And I make this ding 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 ding, and I can write this ding ding equation. I don't need this ding ding equation right now, but we will need it very soon. So N1 becomes equal to M1G. We are not worried about this equation. What we are more excited about is the green one. Green Hulk. This is green Hulk. This is green Hulk, and here comes the green Hulk. Yes. What is the green Hulk equation?
T is equals to M1 A1.
T is equal to M1 A1. Now, as you can see, you have four unknowns: T, A1, A2, A3, and you have four equations. You have to solve them, get your answer, stay happy. How much time you should take to solve this? 10 seconds on the maximum. How do you solve it in 10 seconds? Now, I'll tell you my way of doing it. You can use your own way. What I will do is, please listen to me carefully. I will take the value of A1. Remember, this equation is A3 plus A1 is 2 times A2. Do we understand this? So I will take the value of A1 from here and put it here. Ding, 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 ding. I will then take the value of A2, A3 from here. Ding, 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 and I'll put it here. Then I'll take the value of A2. Ding, 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 I'll put it here. In this way, I will be able to eliminate A1, A2, and A3 from the equation, and I'll get the value of T. Do the calculation in your head. Tell me the value of T. If you have to use copy and pen for this, you will be wasting a lot of time. And time is a luxury, my dear friend, that we don't have. So you can do this calculation in your head. Try it. Get me the answer in the next class, because the time for your class is already getting over. You can do the calculation in your head. Trust me. It's not very difficult. It's quite simple though. See, I'll tell you how I'll do it. A3 is T by M3. So I will write T by M3 plus A1 is T by M1, T by M1. That will be equal to A2 is multiplied by 2. So I'll multiply the entire equation by 2 and divide it by M1. So it will be 2G minus 4T by M2. And then I will transpose it in my head and I will give you the value of T. And I'll give you the value of T very fast. I will tell you that T is 4G upon 1 by M1 plus 1 by M3 plus 4 by M2. See, I did it in less than 10 seconds. When I'm an old fellow. So if I can do it in less than 10 seconds, you should be able to do it in 4 or 5 seconds. and everything in the head. Only the final answer on the paper. We got this? Yes or no? We're gone above our head, sir. Nikal gaya. Gone. Bye bye. Chalo then. Try things like this, because this is how the final equation will turn up for you. Even if you make this equation and take 5 minutes to solve this, it's of no use in the examination hall. You should do it quickly. You should do the entire problem in less than a minute. To write the constraint equation, you should take 3 or 4 seconds. After the constraint equation, to write the equation, you should take 10 to 11 to 12 seconds. And then to solve it, another 10 seconds, 10 plus 20. So you should be able to solve it somewhere around 40 seconds to 50 seconds. 40 to 50 seconds. That's it. You can do this. Well done. If you can't, try. So then I'll meet you in the next class. Take care. Have a nice day. God bless you all, and work on solving the problems quickly. Bye-bye.
Thank you, sir.